Hi everyone. Now that we've covered the laws of logarithms, you see them recapped in the box to the right of the screen. Let's talk about how to express things in terms of single logarithms. For example, if you have the log of a product, that converts to the sum of the logs. The log of a quotient is the difference of the logs. And the log of somebody to a power is the power times the logarithm. Now, the question I have in front of me is express in terms of logarithms of x, y, z, or w, meaning express single logarithms broken out. So log base 6 of xz would be broken into log base 6 of x plus log base 6 of z. So individual logarithms here. Log base 6 of y divided by x would be log base 6 of y minus log base 6 of x using the second rule of logarithms. Likewise, if I have log base 6 of the cube root of z, I can note that the cube root of z is the same as z to the 1/3 power, and using the third rule of logarithms, I can write this is 1/3 log base 6 of z. Again, look back at the instructions. If you're to express in terms of logs of x, y, z, or w, then that's all you want to see inside the individual logarithms. Here's a similar question. Express in terms of logs x, y, z, or w, natural log of the fourth root of the quotient x to the ninth divided by y to the sixth times z. Notice your rules of logs are recapped for you. Notice that the first two rules of logarithms operate without a coefficient in front of the logs, so the third rule of logs is actually the one that you always apply first to go backwards. So if I want to break this apart, the first thing I notice is that I can write the fourth root of this quotient as the quotient to the 1/4 exponent. Now at this point you have a choice. You can use your rules of exponents and raise each term to the 1/4 power, or you can use this third rule of logarithms and pull the 1/4 down and then keep breaking it up from there. It's really your choice, okay? Because the rules of exponents and the rules of logs work hand in hand. Now, if I choose to pull the 1/4 down and I'm going to break some stuff up, then I need some grouping symbols. And natural log of a quotient would be natural log of the numerator minus natural log of the denominator using the second rule of logarithms. And then from there, natural log of x to the ninth would be 9 natural log of x using the third rule minus more grouping symbols because I've got a product here. And natural log of a product would be natural log plus natural log. So I have lots of stuff going on here. Okay, and I'll move it up here. And then we'd have 1/4 all included in the brackets, 9 natural log of x. You can distribute if you want. If I do distribute the minus, I'm also going to deal with the third rule of logarithms here, which would be 6 natural log of y, and then distributing minus natural log of z. Now let's see if we have satisfied our objective. The objective was to take something that's a single log and break it apart into individual logarithms whose arguments would only be x, y, z, or w if you happen to encounter it. So we're good to go here. All right, now something I want you to look to the side. Stop and watch. When you see a watch it particularly the ones like these without the buttons. These are made by UGA's math department. The others are made by the Cengage publisher. Doesn't matter. Stop and watch. Now let's look at a final example where we have individual logarithms and we want to use the rules in reverse and put them back together. So for example, if you had the sum of two logs, it would convert to the log of a product. The difference of two logs would convert to the log of a quotient. And a coefficient times a logarithm would be the log of the argument to the power. Now I noted the last time that you're pulling down the powers as your first step. Here in reverse, you're going to pull up the powers as your first step. So I'm going to have log, and it's base 10 because it's not written, and we went over the special bases, of y to the 6 divided by x squared. Now why the extra parentheses? I'm doing that for WebAssign. WebAssign's functionality requires the entire argument to be enclosed in parentheses. Minus log base 10 of y squared plus log of x to the fourth y squared all to the 1/2 power. Now, you're really not trying to do a bunch of algebra here. You're trying to use the rules of logs. Now work your way left to right. If I have log minus log, that would convert to single logarithm of a quotient plus single logarithm of all the stuff to a power equals log plus log, which is this rule. So we would have log of the first entire argument times the second argument. And really, since we can type this in WebAssign, our objective is not really to do all the algebra inside, but just to meet the rules of logarithms head on.